When calculating branch circuit loads for a computer lab, it is a requirement to use 125% of the nameplate rating. This requirement is specified in Article 645.10b2 of the National Electrical Code, commonly referred to as the NEC. Article 645.10b of the NEC provides the specific requirements for calculating branch circuit loads for data processing units, which include computer labs. Section B2 of this article explicitly states that the load for each branch circuit that supplies receptacle outlets for computing equipment must be calculated in accordance with Section 645.10 and shall not be less than 125% of the nameplate ampere rating of the equipment. This means that for each computer or piece of equipment drawing power from a receptacle on that branch circuit, you must use 125% of the amperage listed on the device's nameplate when calculating the total load on the circuit. This oversizing factor ensures that the circuit has sufficient capacity to handle the computer equipment's inrush current and potential fluctuations in power demand during operation. Let's break down the reasoning and implications of this requirement. Firstly, the NEC is a widely adopted standard for safe electrical installations. It's designed to protect people and property from electrical hazards. Secondly, computer equipment, while seemingly low power individually, can collectively draw significant current, especially during startup or peak processing. Thirdly, the 125% factor is a safety margin to account for these surges, variations in manufacturing, and potential future upgrades to the equipment. Fourthly, Article 645 specifically addresses data processing equipment because of the unique power requirements and critical nature of these installations. Let's discuss the key terms in Article 645.10b2. Branch circuit refers to the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Receptacle outlets are the points in the circuit where you plug in the computer equipment. Computing equipment encompasses the computers themselves, monitors, printers, and other peripherals. Nameplate ampere rating is the current draw listed on the equipment's label, usually in amps, which indicates the maximum current the device is designed to draw under normal operating conditions. Now, consider an example. Suppose you have a computer with a nameplate rating of 2 amps. To calculate the load for that computer on the branch circuit, you would multiply 2 amps by 1.25, resulting in 2.5 amps. This 2.5 amps is the value you would use when totaling the load on the circuit to determine the appropriate conductor size and overcurrent protection. When designing the branch circuit for the computer lab, you would add up the calculated loads, including the 125% factor for all the computers and other equipment connected to the circuit. This total load must not exceed the ampacity of the circuit conductors, which is determined by the wire gauge and insulation type, as specified in NEC Table 310.16. The overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the circuit from overloads and short circuits. Remember that other factors can influence the branch circuit calculations, such as lighting loads, HVAC equipment, and other general-purpose receptacles in the room. All of these loads must be included in the total calculation. Furthermore, the NEC contains requirements for receptacle spacing in commercial spaces. You need to ensure that enough receptacles are available to avoid the use of extension cords and power strips, which can create safety hazards and overload circuits. In situations with high-density computing equipment, it may be necessary to install dedicated circuits for specific groups of computers to avoid overloading any single circuit. Consider the grounding and bonding requirements outlined in Article 250 of the NEC to ensure a safe and effective grounding system for the computer lab. Proper grounding minimizes the risk of electrical shock and reduces electromagnetic interference that can disrupt computer operation. Also, surge protection is highly recommended for computer labs to protect sensitive electronic equipment from voltage spikes caused by lightning or other power surges. The NEC addresses surge protection in Article 280. To comply with Article 645, consider these additional factors. Firstly, the disconnecting means. The NEC requires a disconnecting means for all electronic equipment in a computer lab. This disconnect should be readily accessible and capable of de-energizing all equipment in the room. Secondly, the cable management. Proper cable management is essential to prevent tripping hazards and ensure adequate airflow for cooling the equipment. Thirdly, the fire suppression. Computer labs often contain sensitive electronic equipment, so a suitable fire suppression system is critical. Consider using a clean agent fire suppression system that won't damage the equipment. Fourthly, the emergency power. In some cases, it may be necessary to provide emergency power to the computer lab to ensure continuous operation during power outages. This can be accomplished using an uninterruptible power supply or a generator. In summary, when calculating the branch circuit loads for a computer lab, always use 125% of the nameplate rating of the computing equipment, as required by Article 645.10 B2 of the NEC. This ensures that the circuit has sufficient capacity to handle the load and provides a safety margin for inrush current and future upgrades. Consult the NEC and a qualified electrician for specific requirements and guidance on designing and installing electrical systems for computer labs. Consider a scenario with 30 desktop computers in the lab. Let's assume each computer has a nameplate rating of 1.5 amps. To calculate the total load for the computers, we would first multiply the nameplate rating by 1.25, which gives us 1.875 amps per computer. Then, we would multiply this value by the number of computers, which is 30. This gives us a total load of 56.25 amps for the computers alone. This does not include the load from the monitors, printers, or other devices. Depending on the other loads in the room, this would likely require multiple branch circuits. For example, if using 20 amp circuits, you could put about 10 computers per circuit. It's crucial to also consider voltage drop when designing branch circuits, especially in longer runs. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or not operate properly. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Also, properly label all branch circuits in the computer lab to facilitate maintenance and troubleshooting. Circuit directories should be clear, accurate, and up to date. Consider using a color coding system for the wiring to easily identify different circuits and voltage levels. Regularly inspect the electrical system in a computer lab to identify and address any potential hazards or problems. This includes checking for loose connections, damaged wiring, and overloaded circuits. The NEC also covers the use of flexible cords and cables. Avoid using flexible cords and cables as a substitute for permanent wiring. If flexible cords and cables are necessary, ensure they are properly sized and protected from damage. Furthermore, the NEC addresses the installation of equipment in damp or wet locations. If any part of the computer lab is exposed to moisture, use equipment that is rated for wet locations and take appropriate precautions to prevent electrical shock. When working on electrical equipment in the computer lab, always energize the circuit before starting any work. Use lockout/tagout procedures to ensure the circuit remains de-energized while you are working on it. It is always a good idea to double-check that the circuit is de-energized with a non-contact voltage tester before touching any wires or components. Ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Furthermore, proper ventilation is important for computer labs. Ensure that there is adequate airflow to prevent overheating of the equipment. Overheating can cause equipment to malfunction or fail prematurely. Additionally, consider the use of energy-efficient equipment in the computer lab to reduce energy consumption and lower operating costs. Energy-efficient computers, monitors, and other devices can significantly reduce the overall electrical load of the lab. The NEC also covers the use of alternative energy sources, such as solar power. If you are considering installing solar panels to power the computer lab, consult with a qualified solar installer and ensure that the system complies with all applicable codes and standards. Moreover, the NEC addresses the use of uninterruptible power supplies. UPS systems can provide backup power to the computer lab during power outages, ensuring that critical equipment remains operational. When selecting a UPS system, choose one that is properly sized for the load and that meets the requirements of the NEC. When designing the electrical system for a computer lab, consider the future needs of the lab. Allow for future expansion and upgrades by installing additional circuits and capacity. It is better to over-design the system than to under-design it. Finally, remember that the NEC is a living document that is updated every 3 years. Stay up to date on the latest changes to the NEC to ensure that your electrical installations comply with the current requirements. Always consult the latest edition of the NEC and local electrical codes before starting any electrical work. In addition to the NEC requirements, there may be local electrical codes and regulations that apply to computer labs. Check with your local building department or electrical inspector to determine the specific requirements in your area. These local requirements may be more stringent than the NEC requirements. Also, consider the accessibility requirements of the Americans with Disabilities Act (ADA) when designing the electrical system for a computer lab. Ensure that receptacles and other electrical components are accessible to people with disabilities. The ADA provides specific guidelines for accessible design. Furthermore, think about the security of the electrical system in the computer lab. Protect electrical panels and other equipment from unauthorized access. Consider installing security cameras to monitor the electrical room. Additionally, regular maintenance of the electrical system is essential to ensure its continued safe and reliable operation. Develop a maintenance plan that includes regular inspections, testing, and cleaning of electrical equipment. Keep records of all maintenance activities. In conclusion, the design and installation of electrical systems for computer labs require careful planning and attention to detail. By following the requirements of the NEC, local electrical codes, and other applicable standards, you can ensure a safe, reliable, and efficient electrical system for your computer lab. Always consult with qualified professionals and stay up to date on the latest codes and standards. Keep in mind the importance of proper grounding, surge protection, and ventilation, and plan for future expansion and upgrades. With a well-designed and properly maintained electrical system, you can minimize the risk of electrical hazards and ensure the continued operation of your computer lab. And always remember to prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Also, remember to consider the environmental impact of your electrical system. Use energy-efficient equipment and practices to reduce your carbon footprint. Dispose of electrical waste properly to prevent pollution. By being mindful of the environment, you can help to create a more sustainable future. Consider the use of smart building technology in a computer lab to improve energy efficiency and control. Smart building systems can automatically adjust lighting, temperature, and other parameters based on occupancy and other factors. This can help to reduce energy consumption and improve the overall comfort of the lab.